So, but with the light ones, you can actually see that the liquid inside is opaque white.
Right.
Okay, because it's those crystals of ice formed in the liquid oxygen. Okay, so it's sort of like a wheat paste or something.
Does liquid oxygen, would it normally be the same, just transparent like liquid nitrogen?
No, it's light blue.
Oh, okay. No, right, no, I've seen that. Yeah, they had some, like, you can do fun things with, well, if you're really careful, with fire and liquid oxygen.
Well, you can do fun things with fire regardless.
Yeah, if you're careful.
Yeah, yes.
You have to be a little extra careful than normal.
Yeah, liquid oxygen, yeah.
Yeah. But, like, you can put a flame near liquid nitrogen, like, goes out.
Or you can dump a liter of liquid nitrogen on your barbecue grill and watch it go incandescent white and melt the whole grill into the floor.
Wait.
On your very cheap grill, right?
On someone else's grill. Okay.
Why is that one?
So here,
there now.
can you
Yeah.
see the liquid?
Oh,
Okay.
Yeah.
Okay. So, what was your question?
Well, why does that work?
The barbecue?
Yeah.
Well, the coals are already lit.
Right.
Okay. And so you put liquid oxygen on it.
Oh, liquid
And-
oxygen.
Yeah.
Oh, I thought you.
Yeah.
We thought you were saying liquid nitrogen.
Her question was
It was liquid oxygen.
liquid-
it was,
liquid
yeah.
oxygen.
Yeah, no, liquid
Yeah.
oxygen, yes, and that's what
Yeah.
it is. Right.
So now you can see how cold it is inside because it is condensing the water vapor in the room, and that is falling because it's cold. Okay, onto my
Micro
hand.
rain.
Okay, so who knows if clouds are made out of droplets of water? How come they're up in the sky? How come they don't just fall?
Maybe what's the pressure there versus...
Because they're on an updraft?
No, I mean, I don't think it has to do with the updraft, because even without an updraft.
When they
I-
nucleate.
Is what makes them fall.
Okay. Don't think of a cloud as an object. A cloud is an area where the dew point has been reached. Okay? So, air and water vapor is moving through that area. When the water vapor... Okay, first of all, water vapor, I should ask, which is lighter? Okay? Humid air or dry air?
Try. Well, also with
Depends.
humid air, you have the vapor, so there's some sort of vapor in there.
Okay, let's figure it out from first principles. Air is made out of nitrogen and oxygen. Okay, nitrogen molecules, which is 2 nitrogens, and oxygen molecules, which are 2 oxygens. Okay, so nitrogen is number 7 on the periodic table. So it has an atomic weight of 14 and thus a molecular weight of 28. Okay, oxygen is number 8, so it has an atomic weight of 16 because there's neutrons and protons, and a molecular weight of 32. Okay, so water is an oxygen, which is 16, and 2 hydrogens, which are 1 and 1. So it's only 18. Okay, so water vapor is a whole lot lighter than air. Okay, so water vapor rises. Okay, and it rises, and as it rises, it gets into a place where there's less pressure because there's less air weighing
So
down.
it's
on it.
expanding.
So it expands, and as it expands, it cools. Okay, and so it eventually reaches a place where it's cooled enough for it to condense. So it condenses. Well, now it's liquid water, and it's a whole lot heavier than air,
Right.
and it falls. And it falls until it reaches a point where the dew point isn't there yet. And so it evaporates. Okay?
So then I guess...
And so you get more vapor. And so these things are constantly moving around.
Right.
Okay? And you'll see the bottom of the cloud often looks really flat.
Right, where the
That's
top is fluffy.
That's a thermocline. Okay? That's where suddenly, the cold air is sitting on top of a layer, it's a layer of cold air sitting on top of a layer of warm air. Okay, we call that an inversion layer. Okay, and so the warm, moist air has risen. Okay, and now it cools, it gets into cool, and one of the reasons that inversion layers happen is because there's moisture on the ground. Okay, and so you can have it be warmer and lighter, and the moisture is rising. And when it gets cold enough, it condenses, and now you get a colder.
So I guess then my question would be, what about hail? Because hail is one of those cases where you have the water droplets that are condensing into rain, they fall down, they're not heavy enough to leave, so they bounce back up and they keep going back and forth until...
Hail, you need an updraft.
Updraft.
Okay, and so hail, you often get concentric layers of it because it's going down into where it can melt and where liquid water can join, and then it gets up where it freezes, and then it goes down where it can collect more liquid, and then it goes up where it
until it's
freezes.
heavy enough.
And
so
the
you
size
get-
of the
you
hail
get-
ball depends upon the strength of the updraft.
Exactly.
So is there a reason